Imagine waking up every morning without seeing the sun. No blue skies, no clouds, no mountains on the horizon. Instead, you live hundreds of meters beneath the Earth's surface. At first, that sounds terrifying, but for many engineers and futurists, underground cities may become one of humanity's greatest survival strategies. The world is changing faster than ever before. Global temperatures continue to rise. Megastorms are becoming more destructive. Heat waves are breaking records across continents. At the same time, the world's population keeps growing. By the end of this century, billions more people could be competing for space, water, energy, and resources. Many of our largest cities are already struggling. Traffic congestion, housing shortages, pollution, and rising sea levels. So what happens when the surface can no longer support endless expansion? One possible answer lies beneath our feet. A hidden world of tunnels, chambers, transportation networks, and entire underground communities. A place protected from extreme weather. A place where land is no longer a limitation. A place where the future of civilization may begin. But could an underground city really work? And how much would it cost? Powerful storms cause billions of dollars in damage every year. Some scientists warn that many regions could become increasingly difficult to live in during the coming decades. So where do we go when the surface becomes too crowded, too expensive, or too dangerous? One answer may be hiding beneath our feet. Underground cities could offer protection from extreme weather. They could reduce land consumption. They could create entirely new living spaces without expanding outward. Instead of building higher into the sky, humanity could begin building deeper into the earth. The idea sounds almost impossible, but as you'll soon discover, the foundations for this future may already exist today. When most people hear the phrase underground city, they immediately think of science fiction. They imagine futuristic civilizations hidden beneath the earth, connected by endless tunnels and illuminated by artificial suns. But the truth is far more surprising. The underground world already exists. In fact, millions of people interact with it every single day, often without realizing how vast it truly is. Beneath some of the world's largest cities lies a hidden network of infrastructure that keeps modern civilization running. Transportation tunnel, power systems, water networks, communication lines, storage facilities, and even entire commercial districts. Tokyo, one of the most densely populated cities on Earth, operates an enormous underground transportation network that moves millions of passengers every day. Below the busy streets, a complex maze of tunnels, train stations, shopping areas, and service corridors stretches for miles. For many residents, the underground city is just as important as the one above. Montreal offers another fascinating example. Its famous underground city connects shopping malls, office towers, hotels, restaurants, universities, and transit stations through a massive network of passageways. During harsh winters, people can travel, work, shop, and socialize without ever stepping outside. It functions almost like a second city hidden beneath the first. Singapore has also begun expanding underground infrastructure as available land becomes increasingly limited. Engineers are exploring new ways to move utilities, transportation systems, and storage facilities below ground in order to free up valuable space above. Around the world, governments continue investing billions of dollars into tunnels, underground transit systems, and subterranean facilities. Military organizations have already demonstrated that humans can live and work underground for extended periods of time. Deep beneath mountains and deserts, secure facilities operate 24 hours a day. Some contain living quarters, communication centers, power systems, and emergency resources capable of supporting large numbers of people for months. These projects prove something important. Human beings already possess the technology needed to create functional underground environments. The challenge is no longer survival. The challenge is scale. Imagine combining transportation networks, residential districts, schools, hospitals, parks, shopping centers, entertainment venues, and workplaces into one interconnected underground ecosystem. Not a collection of tunnels, not a temporary shelter, but a fully functioning city, a city capable of supporting hundreds of thousands or even millions of people. It may sound impossible, yet the foundations for that future are already being built beneath our feet. Building an underground city is not simply a matter of digging a giant hole beneath the earth. It would be one of the most ambitious engineering projects ever attempted by humanity. The first challenge begins with excavation. Before a single home, school, or transportation system can be built, engineers must remove enormous quantities of rock and soil. We're not talking about a few tunnels. We're talking about creating enough space to support an entire city. Potentially millions of cubic meters of material would need to be excavated and transported away. To accomplish this, massive tunnel boring machines would operate around the clock. Some of the largest tunnel boring machines ever built are longer than a football field and weigh thousands of tons. These engineering giants slowly carve their way through solid rock, creating the underground pathways that modern cities rely on today. But excavation is only the beginning. Once the underground space exists, another challenge emerges. Air. Every human being needs oxygen to survive. In a city housing hundreds of thousands of people, maintaining a constant supply of fresh air becomes a monumental task. Gigantic ventilation systems would need to continuously circulate clean air throughout the city while removing carbon dioxide, heat, and pollutants. Without reliable ventilation, life underground would quickly become impossible. Water presents another major obstacle. Residents would require drinking water, sanitation systems, wastewater treatment facilities, and emergency reserves. Engineers would also need to prevent groundwater infiltration. A single major leak could threaten entire sections of the city. Flood protection systems would need to operate constantly. Pumps, drainage tunnels, and monitoring networks would become essential parts of daily life. Power is equally important. An underground city can never afford to lose electricity. Lighting, transportation, communication systems, hospitals, security networks, and life support infrastructure all depend on a stable energy supply. For this reason, future underground cities would likely require multiple independent power sources, advanced battery systems, backup generators, renewable energy networks, and highly resilient electrical grids. Transportation introduces yet another layer of complexity. People need efficient ways to move throughout the city. Traveling long distances through tunnels on foot would be impractical. Instead, engineers envision autonomous transit systems, high-speed rail connections, and intelligent transportation networks capable of moving thousands of passengers every hour. Emergency situations create even greater challenges. What happens if a fire breaks out? What if part of the structure becomes damaged? What if a major system fails? Every critical component would require redundancy. Multiple evacuation routes, backup communication systems, secondary power supplies, and real-time structural monitoring capable of detecting problems before they become disasters. The deeper the city extends beneath the surface, the more difficult every challenge becomes. Pressure increases, construction costs rise, maintenance becomes more complicated, and safety requirements become increasingly demanding. Yet history has repeatedly shown that humanity thrives on solving impossible problems. From skyscrapers that touch the clouds to tunnels that cross beneath oceans, engineers continue pushing the boundaries of what can be built. An underground city may seem impossible today, but many of the technologies required to build one already exist. The real question is not whether humanity can build an underground city. The real question is whether we are willing to invest the time, money, and ambition necessary to make it happen. Imagine stepping into an underground city for the very first time. You might expect dark tunnels, cramped spaces, and endless concrete walls. But the reality could be very different. Future underground cities would likely be designed to feel as open and comfortable as possible. Advanced lighting systems could simulate natural sunlight throughout the day, artificial dawns, artificial sunsets, even changing weather effects designed to match the rhythms of the human body. Instead of narrow corridors, residents might walk through wide public spaces filled with trees, gardens, waterfalls, and recreational areas. Engineers and architects understand that humans need more than shelter. They need environments that support both physical and mental well-being. That is why many future concepts include indoor parks, green spaces, and entire ecosystems integrated directly into the city itself. Residential districts could contain apartments, schools, hospitals, restaurants, shopping centers, and entertainment venues. Everything would be connected through intelligent transportation systems. Commuting to work might take only a few minutes. Autonomous vehicles could move silently through dedicated transit tunnels. High-speed trains could connect different districts in seconds. Life underground may actually become more convenient than life on the surface. The environment would be carefully controlled. No hurricanes, no heat waves, no snowstorms, no extreme weather disrupting daily activities. Temperatures could remain comfortable year-round. Air quality could be continuously monitored and optimized. For many people, this level of stability would be highly attractive. Yet life underground would not be perfect. One of the greatest challenges may not be engineering. It may be psychology. Human beings evolved beneath open skies. For thousands of years, we have relied on sunlight, natural landscapes, and direct connections to the outside world. Some people may adapt easily to underground living. Others may struggle with feelings of isolation or confinement. This is why future underground cities would likely invest heavily in creating realistic natural environments. Artificial skylights, massive digital windows, indoor forests, water features, and immersive public spaces designed to recreate the feeling of being outdoors. The goal would not simply be survival. The goal would be creating a place where people genuinely want to live. A city hidden beneath the earth, yet every bit as vibrant, dynamic, and alive as the cities above it. And if technology continues advancing at its current pace, that vision may be far closer than many people realize. Building the world's first true underground city would come at an extraordinary cost. Some experts estimate that a fully self-sustaining underground metropolis could require hundreds of billions of dollars to construct, perhaps even more. The excavation alone would take years. Massive engineering systems would need to operate continuously. Power generation, transportation, ventilation, water treatment, emergency infrastructure. Every component would need to function flawlessly. This would not be a single construction project. It would be the creation of an entirely new world. For many people, such a city may seem unrealistic, too expensive, too ambitious, too far beyond our current capabilities. But history tells a different story. There was once a time when skyscrapers seemed impossible. A time when crossing oceans in hours sounded like science fiction. A time when humans reaching space appeared to be nothing more than a dream. Yet, each of those achievements eventually became reality. The same may one day be true for underground cities. As technology continues to advance, the barriers that once seemed impossible begin to disappear. Artificial intelligence could help manage entire urban systems. Autonomous robots could perform dangerous construction tasks. Advanced materials could make underground structures stronger, safer, and more efficient than ever before. Future generations may view underground cities not as emergency shelters, but as desirable places to live. New communities, new economies, new opportunities, entire civilizations built beneath the Earth's surface. Of course, many questions remain unanswered. Would people truly choose to spend their lives underground? Could artificial environments ever fully replace natural ones? Would future underground cities become symbols of progress, or symbols of a world forced to retreat from the surface? No one knows for certain. What we do know is that humanity has always adapted to new challenges. When space became limited, we built upward. When distances became barriers, we built bridges, tunnels, and transportation networks. And when new frontiers appeared, we explored them. Perhaps the next great frontier is not in the sky, not on another planet, but directly beneath our feet. The world's most expensive underground city may never be built. And if that day comes, if underground cities become a reality, one final question remains. Would you live there?